I will introduce the next speaker, Professor Dubowsky, Steve Dubowsky. And Professor Dubowsky is a professor in mechanical engineering, and now they added another department there. It's aeronautics and astronautics at MIT. And he's also the director of the MIT Field and Space Robotics Laboratory. And his research interest is in the area of design, control of mechatronic and robotic systems, including those for medical space applications. And I can say I've known him for how many years? 30-something years. And I've known him since the time that he was at UCLA. Then he moved to MIT, and he has been there ever since. Before that, he was actually a student of Professor, well, I forgot, Freundestein, which was actually the father of the founders of the robotics field, the modern robotics field. So he was one of the founders. Professor Bernie Roth, who was here at the last conference, is also another founder. And Professor Shoam worked with Professor Freundestein. And this is actually the group that really established the modern robotics from the mechanics point of view. He has quite a few accomplishments. He wrote 300 papers, had quite a few best paper awards. I have written here some award that he received in 2001, but I remember that he received one of the first paper awards that was given to a roboticist. There was sometimes in 1980 something. It was on the adaptive control. It was what time? 78. It was 1978. The robotics has just started, and he already received the best paper award at that time. And he had several visiting positions. I will not mention those. His advisor has been advisor to several government agencies, and he's a fellow of ASME, IEEE, and a distinguished NATO fellow, Paris, France, and an honorary senior research fellow of the United Kingdom Scientific and Engineering Research Council. Now, he has been at MIT for a long time, and recently started his own company that is called PV Pure, P like Peter, V like Victor, Pure like pure water.com. So if you want to see what the company is doing, after he will discuss that in his talk, you can just type pvpure.com. And in fact, when he suggested that his title will be, or the subject of the talk will be about some system that is doing good for people in some remote places, I asked him, how about talking about robots for good? Or in Hebrew, robotov. Those who don't speak Hebrew, robotov, robot is robot, tov is good in Hebrew. It's something that we would like to actually project and propel into the world. So he was kind enough to take this challenge, and the title of his talk is Robotov, an assessment of the contribution of robotics to quality of life. So please give a hand to Professor Steve Dubowsky.
Of all the students I've ever had, Svi was certainly one of the best and most unique of all the students. And I appreciate the invitation. Giving this talk was not easy. The previous person talked about a lot of facts, and I'm going to talk a lot about opinions. So bear with me and give me some space to make some mistakes. Going back, I've been in this field for a while, and we've always promised that robots will change people's lives, that will be a benefit to society. So I'm going to look at some of those promises and try to do an assessment of how well we're doing, and maybe talk a little bit about what the challenges that remain. I'm not going to predict the future. That's really hard. Yoga Berra said it's hard to make predictions, especially when they're in the future. So the main objective is to stimulate discussion, and I know there's at least one person who's going to stand up after the talk and tell me I'm all wrong, because he already said that. The first thing is robotics is such a broad field. For the purposes of this talk, I want to define what I'm going to talk about. And that's an integrated system that consists of sensors, microcontrollers, computers, and actuators that has the ability to interact with the physical world and can perform meaningful tasks with substantial degree of autonomous adaptability. So that's my definition. I gave it. It's mine. I'll accept it. And a good robot, or a robot tov, is one that has a positive, significant positive impact on the quality of life of a number of people. I don't try to define the number, but it's more than one, okay? So the first thing is, in making this talk, this was not easy, so bear with me. I studied hard, and I did a survey, and I started off by saying well, if you want to know what a good robot is, maybe we can talk about I can find out what a good person is. And so I did a survey for about 2 weeks, asking anybody who would talk to me, and some of them won't talk to me anymore, but I asked them for the 10 people that they thought were good, okay? And I came up, nobody agreed. So I sort of shook it around and picked out 10 that had some commonality, and I came up with this group, okay? I hope everybody recognizes all the people here. How many people recognize, there are 12. How many people recognize all 12? Nobody. I will ask you, Israelis, how many of them are Jewish? Okay. So you're, okay, now you have the chance. Which of the two, I shouldn't say that. Anybody know who that is? That's Alan Turing, right. Anybody know who these two dudes are? They're the richest Jews in America. So anyway, now you know the answers. Anyway, so nobody could agree upon, by the way, Barbara Streisand was mine. Of course, I think, she's cool, okay? And I put a couple of Frenchmen in there just to keep our French friends happy. Okay, so for 60 years, and I went back and checked, in the first IFTOM World Congress in 1974, had the first session for International Federation of Machines and Mechanisms on robotics in Newcastle upon Tyne, where I was, and it was good. So we started then, we've been doing serious research for more than 40 years now. You're going to talk about 30 years tomorrow, but it went back before that. And, a lot of the origins were in the nuclear program at World War II, as you see here. And even at that time, the developers of those systems were claiming that the robots that they were building to build nuclear weapons for the mass destruction of humanity had some good aspects to them. And they would help this guy with a muscular disease, and they could use it and that thing. So the results, I started to do that kind of survey. It seems like we academics, I don't think industry does it so much, but when we write a proposal, we always say, and it can be used for something good. So the pattern begins, okay? So the current scores, according to Dubowsky, is that robots in industry are pretty good. They're productive, but, do they help people? Yeah, they probably take some people out of some dangerous jobs and stuff like that, but on the other hand, some people have lost their jobs, well-paying jobs, at least in the United States. The well-paying jobs are now working at McDonald's. So, what is that, kaka? It could be good, could not be good. What? Kaka, yeah, right. That's an English term. My mother used it all the time. So, and then field work, okay? So we've done in agriculture, and there's somebody here who does a lot of agriculture. In the United States, Nobody works in agriculture anymore. It's highly automated, except maybe some Mexicans who might come across the border to do the work we don't want to do. But, you know, the idea about replacing cows with a robot really is not a good idea. So it basically it's fine. I mean, it's good for Israel, but it has little impact, at least in the United States, minimum impact. The big disappointment for a lot of us in the robotics field was Fukushima. Of course, for so many years, we'd say robots were great. They could do disaster recovery. And our friends in Japan had this major program in humanoid robots, long and for years. And the government put billions of dollars in it. And when Fukushima happened, and I've been recently in Fukushima, the robots really couldn't do much, either before or after in terms of the recovery of the systems and stuff, and they're still limping along. So that's been a little bit disappointing. In the area, the score of robots for good robots, doing that as I defined it. One area that we have to evaluate is the military use of robots. Now, are they for good or for bad? Well, it depends on who you are, right? If you're the biggest aspect of military robots, at least in the United States, is the drone, right? It's very effective use, and it's got everybody excited. And if you're an American soldier, okay, it's great. It's good, okay? If you're the bad guy, they don't like them so much. It's not good. So, military robotics is like a lot of stuff on the military. It's a two-edged sword. It depends on who you are and who the bad guys are. Okay, health and rehabilitation. Well, it's important for aging population, and we worked on it. This is our PAM, Personal Assistant for Mobility and Health Monitoring. There's one of these up in Rambam Hospital. Actually, Moshe helped us fix some of our broken parts to it that got screwed up in shipping. But it's up there doing some work with elderly patients and Parkinson's. But then we have the Da Vinci robot, and we have Mazor robots. So that's good. It's very good. It's a limitation. And the limitation that I see is in terms of good, only in good, we defined good, was that there are millions and millions of people in Africa and places like that who don't have health care. And the number that the World Health Organization gives for health care is about $35 a year to keep an African, have him have adequate, or her have what they consider adequate health care. $35. When you compare that to a Da Vinci robot that costs about $2 million, you start to look at, its ability to really influence a lot of people's lives, and many people that need it, okay? And part of the basis of this talk is a book called What Do You Do When You've Achieved Everything You Thought You Wanted? And it's written by a famous Rabbi Kishner, who says, you should do good, okay? And I read this book years ago and took it out again, and so that's where the definition of good comes from. Okay, robots for entertainment. We definitely need robots for entertainment. We go back, we had, R2-D2. This is a robot that's coming out of MIT called Jibo, which will talk to you and follow you around the house, and you can do. Educational value, maybe some value of that. Kids grow up with robots. We'll see. I don't know. Robots for the home? I don't know. This one certainly won't do the dishes. And this we all know is the Rumba, which is the largest selling robot in the world, and it vacuums and cleans the floor. So we have one out of many, a lot. So I don't know. You evaluate it. I don't know if your job in the house, like my job is to vacuum the floor, is happy if you have a robot to do it. Okay. So that's where we sort of sit at this point. I try to understand what this is all about, I mean, I could review it, I can make up numbers and that thing. I try to understand. And I looked at the robotics research. Svi, stop looking at your watch. I started late. In the United States, most of the funding for robotics research does not come from industry. The vast majority of it comes from the governments, and most of that money is coming from the military aspects of it. You know, DARPA spends probably far more than NASA's budget, and robotics is not huge. NASA's budget is not huge at all. I mean, you know, it's a small fraction of one F-35 or what the latest fighter plane is. And I saw a recent interesting analysis of it. Do you know in 2050 the price of one fighter plane, air superior jet plane, will surpass the entire budget of the military in the United States? I've learned that. And so what happens in 2050, what's going to happen is the Navy is going to get it 2 days a week to fly. The Air Force is going to get it 5 days a week, and the Marine Corps will get it on leap year, 1 day. So anyway, so, but most of the fund, we all write proposals, right? You know, try to get money, many of us in academia, and the first judgment is coolness. If the program manager thinks what you're doing is really cool, then he might fund it. Then he thinks he's got to make up a mission that somehow relates to what it is, and that's whether or not it's ESA, NASA, ONR, or CRNS, or any other of the alphabet, MAFAT. MAFAT has funded my research, same thing, right? Then they sort of claim it depends if it has intellectual content, right? And then the last thing is the goodness factor, and they wink this eye at it, you know? They say, yeah, it'll be useful to do goodness for people, okay? So I give you an example. This is a robot that goes for planetary exploration that was funded by NASA, okay? And Microbots, and it did some really cool stuff, and it could also be used for good for search and rescue missions, right? Okay, so in the terms of the cool, we had writing the proposal, we had to do cool graphics, right? A lot of simulations and stuff. And then we had cool words like fuel cells, polymer actuators, nanostate electronics. I went back to it. Stealthy, network communications, and lithium oxide. You put lithium into a proposal, it's much better. You'll more likely get funded. Just say lithium. Just throw lithium out there. It's really good. Program managers don't understand what it means, but you know, if he's using lithium, it must be cool, right? And Svi, this is the one we can't get to play, right? Because we don't know how to play it. Well, I have to get out of it, and I can't figure out. No, let's just skip it because we're running a little bit of time. This shows our polymer actuator-based high voltage hopping robot that weighs 26 grams and will leap more than a meter into the air. And if I could make this video work, I would show you that. But you could see it afterwards if you want. 26 grams. Cool. I had a Canadian student who worked on it, among other things. However, in terms of goodness, you had to say it was good for stuff. So you could say those little balls can go out here into, this is the World Trade Center, and look for people down in the rubble. Yeah, okay. Yeah, I mean, it's good. And then you slip in a little bit into, this is a soldier going down a cave in somewhere in Afghanistan looking for whatever his name was. You know, so you're implying that it could be used for military purpose. It was great, you know. And MAFAT funded this after NASA finished funding it. So, you know, they're nice people and everything was fine. He's retired now, the program manager. So, cool is not necessarily a good robot. We do claim goodness, okay? This is a video
the Stanford
from Stanford on a
robot capable of
just to
flying,
show you we're still doing this search and rescue stuff. I was there last week and I grabbed this video. This is Mark Kekowski's video, and he worked
Recovering
on
from failure.
climbing robots, and here he's working on a flying
Taking
robot.
off
Climbing,
outdoors
flying robot.
using only
Okay.
onboard
They show the
sensing and
pretty
computation.
campus. Everybody
At
loves
Stanford,
their campus.
we are interested in quadrotors because
Right,
they can
motion.
go places where people
And,
and terrestrial robots
you know,
can't.
but
like over this rubble
if you
from an
listen to
earthquake.
this, so they're
However,
going to get their
most
flying robots.
quadrotors
They're
only
going to
have enough
go
battery to
and
sustain a
dig
few
people
minutes
out
of
of
flight
rubble
time.
after earthquakes.
If we look at this picture again, we notice that there aren't a lot of good places to land. There are, however, a lot of clean vertical surfaces available for perching. If
They're
we
still
enable our
selling
robots
the
to
same
perch, they can
robot
stay around
thing,
longer,
you know?
perhaps measuring
And somehow
aftershocks
these little
or
things are
setting
going
up
to
a
rescue
temporary
people out of
communications
an
network.
earthquake.
Once
Or
on the
a,
wall,
you know,
it's useful to
terrorist.
be able to
It doesn't
reposition the
happen,
robot after.
you know? Okay. So when an earthquake happens or somebody blows up a building, you got to get people in there with shovels. And they can pull whoever out there. The robots are not going to. Fukushima proved that. You know, they're just, it's a good story. Okay? So, and then, cool robots. Now, this is coming out of Google. And everybody's seen this.
The
This
Dutch
is a
cycle more
self-driving
than any
bicycle.
other nation in the world.
And the
Almost
goodness
900
factor
kilometers
is
per person.
that bicycles are
But that
dangerous.
also means we have
They can be used
350,000
on the
bike-related injuries. Now imagine that we would make biking safer, smarter and easier by
Get
applying
rid of the
self-driving
bicyclist.
technology to biking.
So the bicycle rides itself. So
We taught our self-driving
Google
bike to
invested
figure
in
out
this
where it
bicycle
is,
and
what's
doing
around
this whole
it,
thing, you
what will
know?
happen next, and what it should do.
And there's no danger, you know?
We leaned
Just
on
goes
Google's
along.
expertise in self-driving cars, but we had to adapt the technology to
But
work
then
on
they
a bike.
screw it up. Because it's great that you don't need a bicyclist, okay?
We decided to add 2 additional features.
But then-
First, you can request the bike to pick you up wherever you are, and we developed a comfort mode, adjusting the pedals
keep
to
the
a
pedals
perfect
in
resting
the right
position.
place. It's very important.
I
It's a
think the
real tough thing.
self-riding bike could really give a boost to the economy because people
Gives you
could
more
also
time to
work,
work, she's saying.
on their bicycle. You work in your
So when
office, you
you're
work in your
riding-
home, you work in your car. You could even work on your bike.
I have so much more time. My kids love it. They're just free. They can go anywhere they want.
This
Anytime
doesn't
they
seem
want.
to fit. Because if you're trying to make
amazing.
bicycles safer, you don't put your kids on it.
At the Fietsersbond, we feel that this is the biggest invention since the invention of the bicycle itself.
At Google, we always put our users first. With the launch of this bike, we believe we do that again.
Okay, so, you know, everybody's using it, right? The guy can see the guy sitting in the Google lab saying let's make a wireless, right? There is a story in my lab in the fact that, I don't think Svi was around then, but what happened was I have a big BMW motorcycle and I didn't know what to do with it because when I moved to Boston. So I put it in my lab and the MIT Safety Health Office came by and they said, you can't have a motorcycle in your lab. It's not rated for a motor vehicle. They said, however, if you remove the gas tank, you pull on a motorcycle and pull the gas tank out, and you take the license plate off and put a sign on that says experimental, it's okay. So they took, you know, the students took a computer terminal and they taped it on with duct tape on the motorcycle with no gas tank. So it looked really weird. And we shoved it in the closet inside the laboratory. And I had these visitors from this small island country, what was it called, Japan, come by, and they looked at this motorcycle sitting in there, and they said, what is this? I said, it's a robotic motorcycle with a computer terminal, and it eliminates head injuries in riders, and they started taking pictures of it. Okay, so you need to do something good. Now I want to talk a little bit about goodness, because this is my little chance to try to do something good. Solar-powered robots to produce clean water for small remote communities. Okay? Nearly 1 billion people don't have clean water in the world, and we all know in purification of water, it's a very energy-intensive process. So solar-powered purification could be really useful. Okay? This is a little bit more serious. But, so here's a robot, right? It consists of a solar panel, PV panels, which you have a changing cloud cover as a function of time. You have wind coming by, and you've got all these pumps and everything, and a smart controller and all that stuff. Hey, my definition here was a robot is an integrated physical system consisting of sensors. You got sensors, microcomputers, and actuators. You got pumps, actuators, microcomputers. Has the ability to interact with physical world. Yes, it's changing water, and can perform a meaningful task. It's a robot, and it's making clean water. Okay? So we ran some experiments, okay? And this shows you the system going along, and you can see my office was wrapped up in this thing. They were doing work there, but you can see the reflection of the clouds on the solar panel, so that we've got this interaction of the system. The system is adapting. You can see the solar radiation going up and down. The water is coming in from tanks here and going into this, and we've added the dye. It's being purified, and so we added the dye. You also see there's a little rubber ducky floating in there, because it's the lab mascot, right? So that's the purpose of the song. Everybody recognize that song? Okay, so, and it's making the water, it's working fine, okay? I like that song. Okay, so the thing about robots, even those that make water, if you can do anything, you've got to do anything useful with it, okay? Just can't fill up tanks on the roof of MIT. So we took it down with the support of the Kellogg Foundation, nice people, they make the cornflakes, okay, down to a small jungle site, a small village of Mayans, okay, in the middle of the Yucatan Peninsula, okay, and in a village that has about 90 families, about 450 people, and they have no clean water, and they can't afford to buy it from Coca-Cola. Among other things, it's an hour drive over dirt roads and stuff, even if they had the money. So we moved along, and we built the system down in the jungle to test it, okay?
This technology is the product of 6 years
So
of research
here's,
on solar-powered clean water systems
I hope I
at
can
MIT.
advance this thing.
Each system operates effectively. Called a prototype system.
So this
was
gives you a
built
sense, I want to get past that other
demonstrate the
stuff.
effectiveness outside of the lab. The MIT team.
So this
with
is
the
a little bit
support
about
of the
our
Kellogg
village.
Foundation,
We had to
installed a prototype
train the
system
people
in a
how to
remote
run
Mayan
it.
farming village
We
in
had
the
to make it
center of Mexico's
autonomous
Yucatan
so that
Peninsula.
they could run it without being there. These are very simple people having, at best, an elementary school education. And this is sort of a testimonial video
unit fits into a small
talking about
garden
the
shed.
system.
However, it
And the
can
people
produce
are
enough
very
drinking
happy
water
with
for a
it.
village of
What they
about
did
450
was,
people.
and this was an
The system
interesting
can
stuff
purify
for us,
captured rainwater, pond water, or brackish well water.
they decided
All
that they
these
were
have
going to charge
substantial
each other
dissolved
for the
solids and
water.
biological contamination.
They were going to sell the
Water
water to
produced meets
each
international
other,
water
the
quality
community, the
standards.
tribe, was
system
going to
is
sell the
configured from
water,
easily
and they're
serviced
going to
or
save
replaced
the money to
components.
pay for
It
maintenance
is powered
and
by solar
employ
panels.
some
Water
people
purification
in the
is an
village, 2 or 3
energy-intensive
operators,
process.
who
Solar-powered water is under 2
were
pesos
now
per 20
elevated
liter
from
bottle.
slash
Commercially
and
available
burn,
drinking
meaning
water
they're
costs
cutting down the
25
trees
pesos
and
is
burning
only
it
available
and
for
selling
purchase in
water
the
to
nearest
everybody
town,
else.
over an hour away.
And so
Pure
it's been
water is produced in the village,
not
a
only
short
a
walk from people's
technical
homes.
success,
The village residents
but it's
have
also
trained to
been
operate and maintain the
a
system.
financial
Mi nombre es Guillermo
success.
Moreno Hernández, soy de aquí de la
Got it.
comunidad Unión
We're almost
20 de
done.
junio.
So,
Yo formo parte de aquí
it
como
makes you feel warm and
supervisor.
fuzzy.
La tecnología está hecha para agua dura. Pues agarramos agua del pozo, pues se purificó. Fueron 3 garrafones, de eso me las tomé yo primero para ver qué tal el agua. Pues sí, me gustó y hasta fecha me lo sigo yo tomando, pues esa agua está bien. El inicio se empezó a cada tercer día, la venta de agua. Eso se vocea por medio de un aparato que tenemos aquí en el centro, pues los que quieren venir a comprar agua en ese momento, pues vienen y ya así le llevan el agua. El dinero, pues nosotros la tenemos ahí ahorrada, o sea, más bien guardado para para cualquier repuestas del filtro u otras cosas, o sea, para darle mantenimiento a la planta. Ahí la tenemos.
Okay. So the good thing is, among other things, is they're now making enough money to pay for their share of the wall that they will have to pay for if Trump is elected president of the United States. But, you know, the water is pretty putrid, and the children were, you know, many of them have distended bellies and parasites and stuff. So, you know, the water is great. Now, to tell you the truth, I had to learn a lot about water. And fortunately, my co-founder of pvpure.com, you can check it, because the more people check it, the better. So we now have, was a water expert, public health individual, and it wasn't hard to transfer the technology, the robotics technology, to this. It just took a lot of effort, but it wasn't hard. So robotics technology is great. I'm done. Okay? So the answer is, the positive answer at the end is that robotics technology has the potential to improve people's lives, to be good. Robotos. And that's the end of my talk.
So I apologize.
The agricultural engineer is not going to yell at me?
No. This was good. You did good. Sorry, I mean, this is really, it's calling for questions and for crowd participation, but we really are running out of time. So thank you for a wonderful talk.
Okay.
And I'm really pleased that you were here.